Welcome to Rizzi. Now we are continuing the chapter that is parabola here. In that, the first topic is a general equation of a parabola. General equation of a conic. First of all, we discuss about conic. So, in earlier classes we discussed about the conic section and the introduction of a parabola here and the standard form of parabola here. And based on that, the general equation of a conic we have, that is, if point x1 comma y1 be the focus and L is equal to ax plus by plus c is equal to 0 be a directrix and E is an eccentricity then the conic equation is a square plus b square into x minus x1 whole square plus y minus y1 whole square, that is equal to e square into ax plus by plus c whole square. Here this is the equation of a conic section. Conic here when the point focus and the directrix L and eccentricity E is given. Let us cross check for parabola here. The general form of parabola, this is the focus I am taking a comma 0. For standard form of parabola I am cross checking here and a comma 0 here. This is the directrix, that is ax plus by plus c is equal to 0 and the eccentricity is here. Eccentricity from the focus to any point on a plane, eccentricity, this is eccentricity. If eccentricity is equal to 1, then the parabola will get the parabola here. If eccentricity is equal to 1, then only it is parabola. Let's substitute. Here we have focus that is a comma 0 and eccentricity is equal to 1 and directrix L is equal to ax plus by plus c is equal to 0. And if we substitute the values here the directrix is not here, not like this. So the distance between these two from the axis to this point is a. Then the equation of this one is x equal to minus a. Here this is a minus a here. The directrix is like this. So in between this one we have, this is minus a, this is a, this is axis, this is L is equal to 0 directrix and this is eccentricity is equal to 1 and the equation of this one is x equal to minus a and the equation of this one is x equal to a. This is in the negative side. So then the equation will become here, this is L x plus a is equal to 0. Then the equation of this one is becomes x plus a is equal to 0. Let's substitute all the values in this expression. So a square, here a square only, a square is nothing but coefficient of x, that is 1 plus 0 and x minus a is nothing but this one x1 y1 x minus a whole square plus y minus 0 whole square and eccentricity is nothing but 1 here and directrix is x plus a whole square. So let's solve this one. 1 into this one, total 1 x minus a whole square plus y square and that is equal to y x plus a whole square. Now expand this one according to a minus b whole square formula, a square plus 2ab plus b square. So x square minus 2a x plus a square plus y square. Here if you expand this in the form of a plus b whole square, x square plus 2ax plus a square. Here cancel the terms x square and x square. So a square and x square. So the remaining values are minus 2ax plus y square is equal to 2ax. So we want only y square, send that term to right hand side, that will become y square is equal 2ax plus 2ax. So y square is equal to how much? 4ax. It is nothing but the standard form of parabola. Standard form of parabola here. From this general equation, the general equation of conic, this is the general equation of conic. According to that, you need to substitute focus and directrix and eccentricity in this expression. This is the most important expression. In this expression, we will get the equation of the particular figure here. If it is parabola, ellipse, hyperbola, like this. For all the conic section, this is the formula here. And the next one is the general equation of a conic. The general equation of a conic is the general equation of conic is ax square plus by square plus 2hxy plus 2gx plus 2fy plus c is equal to 0. Here ax square plus by square plus 2hxy plus 2gx plus 2fy plus c is equal to 0. This is the general equation of a conic here, and from this we have to find the determinant delta, that is equal to abc plus 2fgh minus af square minus bg square minus here ch square is equal to 0. This is the value of delta. Based on this equation and delta, we have some cases here. Delta and the condition, that is h square and comma ab. Based on these two relation from this equation, delta and h square comma ab values, we can find the variations in this parabola here and the conic section. Let us start the conditions here. Conditions involved in conic section. And equation of conic section. Conic is, equation of conic directly I am taking. Conic is ax square plus by square plus 2hxy plus 2gx plus 2fy plus c is equal to 0, and the delta is delta condition. Delta is equal to abc plus 2fgh minus af square minus bg square minus ch square is equal to 0. This is the delta here, and here condition case 1 and this is case 2. What is case 1 and case 2 here? Here case 1 indicates if delta value will be 0. If delta value will be 0, here the delta value not equal to 0. These are the two cases where delta is abc plus 2fgh minus af square minus bg square minus ch square. This can say the nature of this conic section, nature of this equation, nature. What is saying this equation from this condition? Here the first case is if delta is equal to 0, then h square is equal to ab, then the lines are said to be parallel lines. Here in this conic expression, This is the delta condition. If the delta value will be 0, first cross check whether the delta value is equal to 0 or not equal to 0, and if the delta value is equal to 0 and again the condition h square is equal to AB, directly you can say they are parallel. Here this is the pair of straight line equation, also we can say pair of straight line equation. And in next class in intermediate first year we discussed about pair of straight line here. And the second case is if delta is equal to 0, then h square is greater than AB, then they are perpendicular lines, perpendicular intersection of lines, perpendicular or intersection of lines, you can say intersection simply, intersection of lines at one point. And the third case is if delta is equal to 0, then h square is less than AB, then the lines are said to be the point of intersection at real point, the imaginary lines point of intersection at a real point. The imaginary line point of intersection is at real point is called this condition. If delta is equal to 0, this is the condition for parallel line. If delta is equal to 0, this is the h square greater than AB is the intersection of line. If delta is equal to 0, h square less than AB, this is a condition for imaginary lines intersecting at a real point. And the next one is, this is the most important for conic section, and here delta not equal to 0, delta not equal to the first condition, delta not equal to 0, a comma b values also not equal to 0, then only the h value is equal to 0, then the figure is said to be circle. Observe clearly, here just substitute h is equal to 0. So in this expression, in this conic expression, if you substitute delta not equal to 0 and delta not equal to 0, AB values is also not equal to 0, AB values also not equal to 0, only h value is equal to 0. If you substitute the h value equal to 0, this complete term will become 0. So ax, then it will become ax square. I am closing this one, ax square by square plus 2gx plus 2fy plus c is equal to 0. This is nothing but the circle equation. So that's why this is a circle here. And the second condition is, this is a conic equation. We can find the all different types of conics by using this expression here. If delta is not equal to 0 and h square is equal to AB, then the figure is said to be parabola. Then the figure is said to be parabola. And if delta is not equal to 0, h square is greater than AB, then the figure is said to be hyperbola. This is when delta is not equal to 0 and the condition, if the condition h square greater than AB, it satisfies hyperbola. And again in this case, one more we have, delta is not equal to 0, h square is greater than AB, and sum of these two a coefficients of x square and y square is equal to 0, then it is said to be a rectangular hyperbola. And the final condition for this one is delta is not equal to 0 and the h square value is less than AB, then the figure is said to be ellipse. Here this is the equation of conic and this is the condition for delta, and if delta is equal to 0 and delta is not equal to 0, two cases are there. If delta is equal to 0, if the condition x square h square is equal to AB, then they are said to be parallel lines. If h square greater than 0, then they are intersection of line. If h square is less than AB, then the intersection of imaginary lines at real point, and case 2 is here, delta is not equal to 0. delta is not equal to 0, the first case is a comma b are also not equal to 0, only the h value is equal to 0, then the figure is said to be circle. And if delta is not equal to 0, then the condition satisfies h square is equal to ab, then the figure is said to be parabola. And if delta is not equal to 0, then the h square condition, h square greater than ab, it is a hyperbola. And in that same condition, if the sum of two coefficients of x square and y square is equal to 0, then they are said to be, then the figure is said to be rectangular hyperbola. And the fifth point, if delta is not equal to 0, h square is less than ab, then the figure is said to be ellipse here. This is all about the general equation of a conic here, and we will discuss the most important points of parabola one by one here. Now we have to discuss each and every point of a parabola. First of all, I would like to draw parabola set. And this is parabola. And I am explaining each and every point in this figure here. Observe clearly. X dash, y dash, this is origin, and the distance between this point to this is distance between this point to this is, here I am taking a here, this is this point I am taking here a, and this is also minus a, and the point of intersection, here I am explaining each and every point, and the first one I am taking here parabola. This is parabola. So I am explaining each and every point here. Observe clearly. I will draw some more points here. First one, focus. Focus is here. This is the focus. This is the focus I am taking, that is a comma 0. This is the focus. This is the focus is nothing but I am explaining each and every definition. Focus, fixed point that is a comma 0 is called focus, and the second point is P, point P. PBA, P of x1 comma y1 be a point on a plane, point on parabola. And the next one, L is equal 0, directrix. This L is equal 0 be a directrix, L equal 0 be a directrix, and here eccentricity is equal to 1. Eccentricity, I am explaining each and every point. Eccentricity is equal to, E is denoted by E, SP by PM, that is equal to 1. This is eccentricity, the ratio of focus to the point and the perpendicular distance from the directrix to the point. This is equal to 1. Then it is called, and this is called the point of intersection of vertex. These are all we know here. This is a new point here. A parabola intersecting the axis. Sorry, the parabola. First of all, we should discuss about axis. This is called axis. This is called axis. This is called focus. This is called point. This is called directrix. And now this is called axis. So axis is nothing but the point focus is passing through a line is called axis. Here the focus is passing through this line, so this is called axis here. And the next one, vertex. Now we can discuss about vertex. The point of intersection of parabola and the axis is called vertex. The point of intersection of parabola and axis is called vertex. Vertex is denoted by capital V. It is denoted by capital V here. Vertex is nothing but the point of intersection of parabola and the axis is called vertex. This is vertex. This point is called vertex. And here next point is there any points? Now these are the most important point. This is one line, this is one line, this is one line. A line, chord. Next point is chord here. Focal chord or chord. Focal chord, normal chord. First of all, we discuss about chord here. Chord. A chord is passing through parabola. A line is passing through axis and intersecting at 2 points of parabola. Here this is a chord, this is a chord. This chord is intersecting at 2 points and passing through the axis is called chord here. And the focal chord. What is focal chord? A chord is passing through focus is called focal chord. Here if a chord, one more chord is passing through this focus point and intersecting at 2 points of a parabola is called focal chord. A normal chord is nothing but a chord is passing through axis and intersecting at 2 points of a parabola is called chord here. And this is nothing but this line. This is the most important line. This is the latus rectum. Latus rectum. And this is the most important point here. I am erasing this one. Latus rectum. Latus rectum. What is latus rectum? A line which is passing through focus and perpendicular to the axis and intersecting at 2 points of the parabola. A line which is passing through focus and perpendicular to the axis and passing through and intersecting at 2 points of parabola. 2 points of parabola. Here latus rectum is nothing but, here this is a line which is passing through focus and perpendicular to the axis and intersecting at 2 points of a parabola. And for example, if a comma 0 be a focus and the distance to the axis is a, then the length of latus rectum will become 4 into a, 4 times of this value here. Length of latus rectum become 4 times of a. So, and the next one, latus rectum, this is latus rectum. Latus rectum is nothing but a line is passing through focus and perpendicular to the axis and intersecting at 2 points of the parabola is called latus rectum. And the next one, double ordinate. Yeah, I am writing here double ordinate. Double ordinate is nothing but here a line which is perpendicular to axis and intersecting at 2 points of a parabola is called double ordinate. Double ordinate is nothing but a line which is perpendicular to axis and intersecting at 2 points here, intersecting at 2 points of parabola is called double ordinate. And we will discuss in next class double ordinate points and lateral rectum points and length of lateral rectum, length of chord here in all the points in next class. Now I am explaining what is the definition of double ordinate and latus rectum and length of latus rectum, axis, vertex, chord, and observe clearly this is double ordinate and chord here and the latus rectum and focus, directrix, vertex, point, all these points we have discussed here. We have discussed the points. First one I am repeating the points here. You have to remember the points of parabola. First, focus. What is focus? And what is directrix? And what is, third point is what is vertex? Fourth point is what is axis? And the fifth one is what is latus rectum? next eccentricity, next eccentricity and double ordinate, next double ordinate chord, next focal chord, next we have these points, and we have principal axis. Principal axis is nothing but this is the principal axis here, and we have various types of parabola, various types of parabola based on coordinate axis here. So in this session we discussed about the new definitions of focus, directrix, vertex, axis, latex rectum, eccentricity, double ordinate, chord, focal chord. All these points we discussed, and in next session we will discuss various types of parabola based on coordinate axis, and this is the diagrammatical representation of parabola, and in this diagram we can conclude all the points here. This is focus, vertex, axis, double ordinate and latex rectum, point, directrix. All these points are we have discussed here. In next session we will discuss about various types of parabola in coordinate axis, coordinate 1, 2, 3, 4. Thank you.